This is part of the ASCII code. You can see it starts with 32, so some numbers are missing here. But it ends at 127, that's correct. Because the ASCII code length is 7 bits. And we have added a leading 0 to make it 1 byte. We have put a leading 0 to make it 8 bits or 1 byte for the ease of use, but that 8th bit doesn't represent anything. It's 7 bits which are usable here. So if it is 7 bits, you know that we have 128 combinations, starting from all 7 zeros to all 7 ones. So you get the 127, which is all 7 ones, but all 7 zeros and up to 32 is missing here. So there's more in this character code, right? ASCII character code. But the last one is this. This is correct because all 7 bits are ones. That is 127. So between 0 and 127, you have 128 combinations. That's all zeros to all ones. Right. And then also you can see that this represents uppercase characters, lowercase characters, special characters, and also some space, del, delete, space, and some other functions also. If you have the full character set, you will notice that. And those are called control characters. Control characters, they actually perform a function, not just putting a letter or a number on the screen. You know that del is for delete, space is to keep spaces. Right, so we have control characters, we have special characters, that's these, and then we have uppercase letters, we have lowercase letters, and also we have numbers. Right, the whole set is represented in the ASCII character code. And the first column is the denary number for that ASCII code, and second column is the binary ASCII code, which has 7 bits usable, but made it 8 bits. And then you have the character. All right. So we learned 2 functions. One is odd, which will return the ASCII denary number if you pass a character. Then we looked at CHR, which will return the character if you pass the denary number. Okay, I think we did a couple of exercises, right? We tested the odd function. We tested the CHR function. Yeah, that's the one. That's all. Huh? Yeah, we did this, no?
Yes, sir.
This was the last one, right? So in school, they just started, or where are you in this? Did you go for image file size and sound file size? Or?
So we're on page 133.
Oh, 133, right? Okay, fine. Did they do these codes? These codes,
Yes.
did you do them in school?
Yes.
Right. So this one, what happens is, yeah, my string to blank for count in range. For count in range 0 to 3. So that will go from 0 to 2. That's 3 times. It'll loop 3 times and asking for you to enter a number between 65 and 90 and or 97 and 122. And then that number will be passed to CHR function to get the letter, corresponding letter. That corresponding letter will be merged or concatenated to my string. So it will keep on concatenating this character, and finally it will output this string, something like this. So 65, 66, and then we'll take 97, and you get capital A, capital B, simple A. All right. Then this one, did you do this also in school?
No, sir.
Yeah, that's a bit complicated. Actually, this is not needed because this explains how the odd function would work. Right? In odd function, when you pass the number, it is going to output the character. I'm sorry. When you pass the character, it outputs the number. Yeah. Odd gives the number. Needs to take the character as a parameter. Yeah. So odd gives the number. CHR gives the character. So for odd, you need to pass the character. For CHR, you need to pass the number. So this tries to explain how the odd function actually works. It's already written. It's a built-in function. And how does it work? When you pass the character for the odd function, it is returning. Now you know the subprograms, no? So if it is a function, there should be a return statement. It is returning the code. And to return the code, they have a 2D array where they store the character and the denary number. So when we pass the character, it matches the character using a loop. It goes to the 2D array and matches the character. And if the character is matched, it will output the second column, which is the number. So you can see array ASCII index 1. So first is the row, second is the column. I think you haven't done 2D arrays, no? 2D arrays, we have done 2D arrays. So in 2D arrays, the first parameter is the column, sorry, row, second parameter is a column. So you can see second parameter is 1. 1 means in each sub-array, this will be 0, this will be 1. This will be 0, this will be 1. So 1 is the second column. So if the character is matched, this should be equal, not hyphen, right? If the character is matched, it will bring the second column value, which is the number. And number is stored in code and it will be output here. Understand? So when you have a, understood?
Yes, sir.
So when you have free time, you just run this function code and see, right? So first you define the function and then you need to call the function by passing a character into it. Okay. And did you do this one in school? Encryption example. No? This one? The Caesar cipher?
Sir, ma'am gave it for homework.
All right, okay, fine. So let me explain that to you. So with the use of odd function and the CHR function, we can easily create a Caesar cipher example because Caesar cipher uses shifting of characters. So all you got to do is something like this. First, you need to ask the user to enter the plain text. So let's write something like this: get plain text. Okay, plain text equals input. It's a text, so I'm not using int. Enter your plain text. Okay, now in that plain text, you need to read each character one by one. Why? because each character will be encrypted. So to read each character, you can use a for loop for character in range. Right. Now you have to assume that this is a, now you need to remember that this is an array. This will be a 1D array, right? If this is a string, if you're inputting a string, this will be a 1D array. In a 1D array, you can access each character using the index. So for character in range, index 0 to length of the plain text, So you know that it will go 1 less than the length of the plain text. When you put like this, that's fine because we start with 0. What do you have to do? Let's first print. Let's first print each character. So plain text. And you have to use square brackets because it's a 1D array. And the index number is stored in character. Or let's use index, that's easy. Right. So index, plain text index will be printed. So this is supposed to print each character in the plain text. Let's call this C is a cipher. Cipher is another name for encryption. Okay, so computer, there you go. You get each character printed separately. Now what do you have to do? You need to pass each character into the odd function to get its denary ASCII value. Because you're going to shift each character using the denary ASCII value. Because if the denary ASCII value of capital A is 65, and if you are shifting it 3 places to the right, you just add 3. So it will be 68. So capital A will be encrypted as 68. What is 68? 65 is A, 66 is B, 67 is C, D. So capital A will be encrypted as D. Right? For that, we need to get the ASCII denary value. So how do you get the ASCII denary value? You can simply pass this character, which is this one, into which function? Odd function or CHR? I want to get the ASCII denary value of the character.
Odd.
Odd function, good. So for the odd function, you pass this character, and now it's supposed to print the denary value, denary ASCII value, computer. There you go. Right, you get the denary ASCII value. Okay, now the encryption is not complete if you don't give a key. That key is the number of places it is going to be shifted. So we need to ask another question, right? Let's say key input. Enter your key to encrypt. Right. This is supposed to.
So I
Pardon?
explain it.
Yeah, sure. Right. So what I did was this, right? I tried several times and somehow got it. So 32 is the ASCII denary for space. 46 is the ASCII denary for full stop. So here I am converting all the characters into the cipher number. I told you, you can do it in 2 ways. You can check the space and space or the dot at the beginning, or you can convert everything and check whether 32 and 46 is there. Now the problem here is cipher number has got the result of the odd added with the key. So what I did was I took 32, added the key to that, the same key. So if the key is 3, this 32 would be 35 after adding the key. So then I checked whether cipher number is 35 or cipher number is 49. If the key is 3, the key can be anything, right? So that's why I'm adding a key, not 3. So what I'm doing here is I'm converting all characters, convert all characters into denary ASCII with the key. With key added. And then here I'm checking whether that cipher number is 32 plus that key. So it is 35, but it is actually checking the space. Right? Why am I adding this key? Because the cipher number is already added with that key. So if I'm checking for 32, I should add that key as well. Or I'm checking whether that cipher number is 46 plus key, because 46 is the ASCII number for dot. So you add the key and see whether that's this number. So if this is true or this is true, what you do is you just concatenate. So what I did was, without printing each letter, I started concatenating the cipher text, building up the cipher text. So I concatenate the plain text index, which is the actual character, space, or the full stop, into this, into the cipher text. If I'm taking the plain text index, I'm not passing this cipher number into CHR and getting the output, because I'm not passing 46. I'm passing 46 plus the key, which is wrong. 46 is the dot, 32 is the dot. So what I'm doing is I'm just taking the plain text character and concatenating it to ciphertext. Else what I do is, if it is not the space, if it is not the full stop, I take the cipher number, put it to CHR, get the letter, and that letter is concatenated to ciphertext. So whenever it comes across space, it is just concatenated. When it comes across anything else other than the space or the full stop, it will be putting it to CHR function to get the encrypted letter and concatenate it to this. So the main difference is here, I'm checking whether it is space or the full stop. If it is true, I am not taking the output of CHR, I'm just taking the letter from the array and adding it to that. Otherwise, I'm passing the cipher number into CHR, getting the encrypted letter, and concatenate it into this. So when I input I go home with a space, 2 spaces and a dot, you can see space is there, and the dot is there. Got it?
Yes, sir.
Right. So you go a little bit further. Right. So I'll talk about the extended ASCII and Unicode and then stop. And then we'll talk about the rest in the next class, right? Next class in this, I will have another session, another 1 hour session. Okay. And perhaps an extra class, but definitely 1 hour session to cover the next 1 hour, right? So the extended ASCII was an extended version. Give me 10 minutes. Right. Why is it called an extended version? Because the standard ASCII used 7 bits. but an additional bit was added to make it 1 byte. But that byte, that one additional bit, the leading bit, the leading 0, was not used. It was just a dummy bit. But in the extended ASCII, they used 8 bits to represent the characters. All the 8 bits were usable. So you know that if there are 8 bits, the total number of combinations you can have is 256, because 2 to the power 8 is 256. So if this was used properly, unfortunately, it was not standardized. If it was used, because some manufacturers used, some didn't, so it didn't become a standard. If this was used, you could have represented more characters because it had 256. But 128, the standard ASCII, was more than enough to represent those control characters, capital characters, lowercase, and numbers and special characters. That was more than enough. But then the problem was, what about the other languages? So ASCII was mainly developed for English, but what about the other languages? If you want to represent other languages, there are so many characters. Then they came up with another standard called Unicode. Now, Unicode is used to represent almost all the languages in the world because it uses 2 bytes or 4 bytes, mainly 2 bytes. So if 2 bytes are used to represent each character, that is 16 bits. So you can have 2 to the power 16 number of variations. That's more than enough to represent any language in the world. So the Unicode was introduced, but what you should remember here is, if you have 16 bits, within that 16 bits, you have that initial 7 bits of ASCII as well. Because ASCII is 7 bits, Unicode is 16 bits. Within those 16 bits, you have the first 7 bits as it is. That means if you take Unicode and ASCII, the first 128 bit patterns are the same. Understand?
Yes, sir.
Right. First 128 bit patterns means 0 to 127 are the same for ASCII and Unicode, but they can represent different languages, English and any other language. So now this is why we have now Unicode has become a standard. Before that, there wasn't a proper standard. If you take if you took Sinhala or Tamil, different people came up with different combinations. So one person's Sinhala font was different to another person's Sinhala font, not by the shape. I mean, if you use a particular letter in one person's character code, it is not the same in another person's character code. For example, if you have 2 Sinhala fonts, if you type iron in one, in the other one, it's not iron, it's a separate one. Same was there with Tamil. What happened was they brought it into a standard, and now most of the Tamil and Sinhala fonts are designed to go with the Unicode character set. So if you use Unicode Sinhala fonts or Tamil fonts, the letters will be the same in all those types of fonts. Okay. So if they ask you to compare ASCII and Unicode, the differences would be ASCII uses 7 bits to represent characters. It's used mainly for English. Unicode is used to represent other languages, and it uses 16 bits. Then both are standards. That's a similarity. Another similarity is in both the first 127, 128 bit patterns are the same. Understand?
Yes, sir.
Right. So we'll continue with the rest in the next 1 hour, which will be within this weekend. I'll check a time with you. Okay.
Okay, sir.
Okay then. See you. Good night.
Thank you, sir. Good night, sir.